Okay, now let's talk about the experiment we need to finish today. First is part 1. So the purpose of part 1 is just for you to practice how to use the oscilloscope. Basically, you just need to follow those steps and get familiar with the oscilloscope. But one thing is about the compensation signal. In part 1, we use this compensation signal instead of the function generator. So it's located here at this corner. There are two holes here. So for the oscilloscope, we have two channels. Each channel will have a probe. At the end of the probe is a black clip and a hook. So to connect to the compensation signal, we just connect the black clip at the ground, the lower hole, and put the hook into this hole. That's how we connect the compensation signal. Because the amplitude and the frequency of the signal is fixed, we often use the signal to check whether the oscilloscope or the probe is normal before we starting our experiment. Now going back here, remember our purpose is just for you to practice, so you don't actually need to answer those questions. It's more like a reminder. You don't need to put the answer in the template or in the Canvas quiz. For part 2 is our real experiment. When building the circuit, if you're using Tinkercad, for Tinkercad it's an ideal simulator, so it doesn't including any internal resistance. But to be close to the real situation, if you're using Tinkercad, we need to add this internal resistance, a 50 ohm resistor for the function generator. But if you're using the real function generator, it's already included, so you don't need to add this. Next step, we attach one resistor at a time to the circuit here. So we're going to replace this 1 kilo using these 5 resistors each time and use the oscilloscope to measure the voltage across it. And next step is to calculate the internal resistance of the function generator using this equation. So the Vs is this 10 volt here, and this VR1 is the voltage across the load resistor, what we measured here. Then multiply the resistance of each resistor. The last step is to plot the internal resistance we calculated versus the resistor value. So the x-axis will be the resistance, and the y-axis is the internal resistance. And we gave 20% error margin, so if your calculation is between 40 to 60, you'll be all good, because the internal resistance is just 50 ohms.